One of the greatest roadblocks for newcomers to data science and deep learning is the multitude of terms present on even the most introductory courses. The field has steep learning curve as most concepts are intertwined and complementary. To make things worse, most newcomers have little to no machine learning background, making tasks even harder. In this video, I break down some of the field's most important concepts in a sequential manner, linking each new term to the last. Let's start with the definition of intelligence. So far, no commonly accepted definition for intelligence exists. The definition is an ongoing debate that spans a wide range of fields and disciplines such as philosophy, psychology, sociology, and computer science. According to Wikipedia, intelligence has been defined in many ways. That's the capacity for abstraction, logic, understanding, self awareness, learning, emotional knowledge, reasoning, planning, creativity, critical thinking, and problem solving. However, although no definition is widely accepted, science has been trying to mimic intelligence for decades, creating artificial intelligence, the field within computer science that studies intelligent behavior in machines. In other words, systems that behave in non trivially predictable ways, systems that react and appear to reason about themselves and the world around them. This definition is vague as we can't even define intelligence properly. However, something that we can define is learning, which brings us to machine learning, the task of showing the inputs and outputs of a problem to an algorithm and letting it learn how to solve it. For instance, to create an algorithm that recognizes dogs and cats in pictures by showing it hundreds of photos of pets. With an ML, a growing approach is deep learning, the idea of stacking multiple learning algorithms to jointly solve a difficult task. When we are kids, we learn the alphabet, then we learn to read simple words, then full sentences. Artificial neural network. Among several ways of implementing deep learning, neural networks are by far the most popular. In short, they are a stack of simple learning algorithms called layers that sequentially process the input, producing an output. Network layers. All neural networks are made up of layers. A layer defines an operation that takes some inputs, some parameters, and produces a set of outputs. For instance, the dense layer. It is the layer that receives a vector and multiplies it by a matrix, producing another vector. While this is one of the most widely used layers in practice, it has a problem. It is linear. Something is linear when it can be decomposed as independent parts. This makes them easy to study. However, a linear system is no more interesting than the parts that make it. A plus B is no more interesting than A and B themselves. This is opposed by nonlinear. A system is nonlinear when its parts are intertwined as a complex whole. A nonlinear system cannot be easily factored, hence, the whole is more than the sum of its parts. For instance, sin A plus B cannot be broken down into A and B terms. Thankfully, any linear system can be made nonlinear by means of an activation function. These are ordinary nonlinear functions used in deep learning that have the sole purpose of receiving input and making it nonlinear. Within deep learning, the most famous activation function is the ReLU, short of rectified linear unity. This is one of the simplest and most efficient ways of making something nonlinear. That's why it is so popular because it's simple and fast.